Hello friends, I am Tarun and today we are going to learn how to make a matrix. Matrix of LEDs. Now how the LEDs are going to help is firstly the number of pins or switches we are going to use will be reduced. Say if an LED has two terminals, one positive, one negative, and we are using let's see we are having 10 LEDs and we are making the ground common of each LEDs. Ground common. So the number of ground terminal will be 1 and rest left 10 positive terminals, right? 10 positive terminals and 1 negative. So now the number of total number of pins we are using is 11. So now this can be reduced in as we can say, if we are using 10 LEDs, so we can join them in 2 cross 5 manner, that is 2 rows and 5 columns, fine. So 2 rows, let's see, 1 2, number of LEDs 1 2 3 4 5, 1 2 3 4 5. The ground of each of the LEDs is common, so let's just take positive terminals, positive 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 positive. So if the ground is common, fine, the ground is common to all the LEDs. Now if you want to turn on any one of the LEDs, let's say if you want to turn on this, then we will give a ground to this and the positive to this LED. So this LED will glow. If we are not giving positive to this and giving positive to this terminal, then this LED is going to glow. Now what does a matrix do? Let's just create a matrix. Let's say we have the same number of LEDs, 10 LEDs connected in 2 rows and 5 columns. 1 2 3 4 5, 1 2 3 4 5. If we take the ground of each LEDs to a single row R1 and other 5 LEDs to row R2, these are the ground terminals. So total connection will be 2 terminals or pins will be used. Now let's consider the positive terminals. If we join the positive terminals, let me take another marker. Here it is. If we take positive terminals of these LEDs, this side C1, these 2 LEDs C2, these 2 C3, these 2 C4 and these 2 C5. So number of positive terminals will be reduced from number of positive terminals will reduce. Now as you can see, number of positive terminals are 1, 2, 3, 4, 5. So positive terminal equals to 5, and as we have seen, number of negative terminals were 2, positive are 5, total are 7. But in our previous case, there were 10 positive terminals and one negative terminal. Fine. So 11 were there, and now we are having 7. So 4 pins or terminals are reduced. So if your microcontroller is having less number of pins left, so you can use the matrix method. Now what is the benefit of matrix method? I am going to show you in a while. Let me just erase it, and how it works, that too. Let's say we have 25 LEDs of 5x5 matrix. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, number of 5 LEDs. So it creates a square-like figure. Fine. If we take all rows as ground, one row ground 1, second row ground 2, third row ground 3, similarly ground 4 and ground 5. 5 negative terminals. Now let's consider the positive terminals in the column side. So if we take all these LEDs in single terminal to column 1, that is let's say VCC 1, VCC 2, VCC 3, VCC 4 and VCC 5. So 5 terminals, 5 positive terminals here. So to operate 25 LEDs, all we need is 10 terminals or pins of microcontroller unit. So the number of pins will be reduced in the matrix form, and the working will be the same. If we consider all the LEDs in the are not connected to each other in matrix form, then total number of pins will be say 2 legs of each LED, 2 into 25, there will be 50 pins used. Fine. Or if we consider ground as common, so the pins will be half plus 1, because ground will be common for all the LEDs, and when we will give positive to any one of the LED, then that LED will be glowing. But reduction to 10 terminals of pin will be more comfortable. So let's just study how the matrix work now. The connection will be same for 2x2, 4x4, 2x3, depending upon how many LEDs you are going to use. Fine. Now let's just concentrate on this matrix. If this is LED 1, name it on the matrix as we have studied earlier in mathematics. Let's say it's 1 1, 1 2, 1 3, 1 4, 1 5, 2 1, 3 1, 4 1, 5 1, and so on. There will be 5 5. Fine. Fifth row, fifth column. So if you want to glow any one of these LEDs, what you have to do is, firstly, all the LEDs will be, say, all the terminals are not connected to any, not connected to neither through VCC neither to ground. So if you want to glow, say LED, this LED, you have to give ground to this row and ground to the column at which this LED is connected, that is VCC 3. If we are ground, let me correct, VCC to the column which is which the LED is connected to. Fine. If we are giving ground to this LED row, this row, that is ground 3, we are giving ground, that is 0 volt, and the same terminal of the battery or the adapter you are using 5 volt or 3 volt with the resistance in series with the LED, so that LED don't blows up. So the VCC to the same column, this LED will only glow, since no other LEDs are getting the all two terminals connected to a battery or the adapter. So if you want to make a pattern, say we want to make a pattern of glowing 1, all you have to do is glow 1 2 3 4 5 column 3 LEDs in vertical, all simultaneously. Either if you are using microcontroller, you can give a delay so that the brightness will be comfortable. If you are not using any triggering circuit, that we will further study how you have to amplify the voltage. Since if the LEDs are glowing together, the voltage or the current reduces, that will affect in the intensity of the LED. So if you want to glow this LED, say if you want to print the number 1, so you have to glow 1 3, 2 3, 3 3, 4 3 and 5 3 of this column. So all you have to do is give VCC to the column 3 and ground to each of the rows. Fine. When each of the rows are getting ground, means the circuit is completed. The circuit will grow from here and connect to this. The circuit will go from there and connect to this. Hence, negative terminal, positive terminals are short circuited with an LED, so the LED will be glowing. In this way, you can work all the LEDs. So this is for all for today. Next we will consider another lecture, how to glow how to perform other operations on the matrices. Thank you and have a nice day, friends. Please subscribe, share and like.